Okay, here we have a very simple yes or no question for many of the more clever students in the class. I'm sure you could realize that with 10 tries, you can get a correct answer within 2 tries, assuming there's only two options here. At most, there might be 3 or 4. Um, but that, of course, doesn't get to the understanding of the question, and it doesn't help you if these numbers are changed on the exam so that this answer flips between yes and no, which they do that. So we have a huge survey of college freshmen and found that almost 2/3 of them ended up attending their first college choice, which is, I would say, a fairly positive result. So if we take a random sample of 110 freshmen, and we want to make sure that at least 50 in our sample are attending their first choice. So maybe we're going to do some comparison between those who are attending their first choice and those who are not, and looking at retention rates between the two groups, if they're different, GPAs, things like that. It would actually be pretty interesting, but we want to make sure we have enough who actually are attending their first college choice. So can we be assured that we'll get at least 50 students, or can we be reasonably confident? So we have to go through a proportional distribution here. What I've done in Excel is I've left the work from, what was this, E36, where we had the Hispanic surnames. And I just want to show you the nice part about Excel when you're using formulas that reference different cells. So here I'm going to have a survey, a sample of 110 instead of 500, and my proportion is 0.61. Notice that that also changes my 1 minus p, my NP, everything. So in that sample of 110, I should be, my mean, if I did this several times, would be to get about 67 students who are attending their first choice college. Where do I get that number? Well, that's 61% of 110. So that would be my most likely outcome, or at least the mean. And I guess I should mention also that my NP and N1 minus P are both over 10, so I'm assuming a normal distribution here. So the other thing to take into account is the square root of n times p times 1 minus p, which is the standard deviation, so 5.11. So what I want to know is how much of a chance is there that I'll get less than 50, knowing that the mean of this normal distribution is 67 with a standard deviation of a little over 5. Well, real quickly I can see that 50 students would be over 3 standard deviations under the mean. So I'm thinking this is unlikely, but let me go ahead and calculate the actual random distribution. Oh, sorry. Let's do normal distribution. That'll be better. And we want 50, where our mean is 67. Standard deviation is here. I think I put too many parentheses in there. And the next question to ask, is this the proportion I wanted? Yes, because I'm looking at, well, this is the proportion that I would have less than 50 students attending their first choice college. So less than 1%, much less than 1%. Again, like I said, over 3 standard deviations below the mean. This is very unlikely that I'd be under there. So 99.9% of the time, I'm going to be over at least 50 students attending their first choice. So yes, I can be reasonably confident that that'll happen.